From millions of miles away, the brightest object in our night sky looks like a peaceful, glowing jewel suspended in the dark. This diagram compares Earth and Venus side by side, showing why they are physical twins. They share nearly identical diameters and mass. Stripping away the atmospheric layers reveals matching internal structures, a dense rocky mantle wrapping an iron core, forged from the same cosmic dust. But the moment you pierce those bright yellowish clouds, the peaceful image disappears. Below, the surface is a pressurized wasteland constantly engulfed in heat. Venus demonstrates how identical planetary ingredients can produce radically different outcomes, proving the solar system operates on a scale of unpredictability that defies common logic. Look closely at the barren, sun-scorched craters of Mercury in this provided image. Because it orbits closest to the Sun, a simple logical assumption suggests it should be the hottest object in the solar system. Yet, the dense atmosphere of Venus, shown here, traps enough energy to reach 475 degrees Celsius, hot enough to melt solid lead, despite being nearly twice as far from the Sun as Mercury. This diagram illustrates the mechanism driving that heat. A thick atmosphere composed almost entirely of carbon dioxide allows solar radiation to enter, but acts as a physical barrier that prevents heat from escaping back into space. This runaway greenhouse effect proves that a planet's chemical composition is a more decisive factor in its surface temperature than its proximity to a star. These bizarre mechanics extend to the planet's rotation, creating a timeline that is functionally broken. Notice the two circular timers in this animation. The top timer tracks a full orbit around the Sun, which takes 225 Earth days, but the bottom timer, tracking a single rotation on its own axis, takes 243 Earth days. A single day on Venus lasts longer than its entire year. And as the directional arrows show, the planet spins clockwise, while nearly every other planet turns counterclockwise. Astronomers suspect a massive, ancient collision with an asteroid physically knocked the globe into a permanent backward spin. That single cataclysmic event permanently rewrote the planet's physical orientation and its relationship with time. This terrain appears volcanic and rocky, but the gas surrounding it is so dense that the physical environment mimics the crushing conditions found at the bottom of an ocean. The weight of the carbon dioxide creates an atmospheric pressure 90 times heavier than Earth's. Standing on this surface provides the same physical stress as being submerged 1 kilometer underwater. When exploratory probes enter this environment, the intense mechanical force often results in the titanium structures collapsing inward within minutes. Above this weight, thick clouds drop a steady rain of sulfuric acid. Because the surface is so hot, the acid boils and evaporates back into vapor miles before it can ever strike the ground. The deadly combination of lethal pressure, acidity, and heat creates a surface that is currently inaccessible to traditional physical exploration. While the surface remains unreachable, researchers have turned their attention upward, toward the temperate cloud layers 30 miles above the ground. This diagram illustrates a molecule of phosphine gas, a chemical signature scientists believe they have detected within these cloud bands. On Earth, this gas is produced by anaerobic bacteria. No known geological processes can account for its presence in these quantities. This raises the possibility that microscopic organisms could be drifting through the skies of the solar system's deadliest planet. If further missions validate this chemical signature, it suggests that life might find a niche within specific pockets of stable air, independent of a solid surface or liquid oceans. For decades, the extreme conditions on Venus led the scientific community to prioritize Mars. These new anomalies are changing that focus. Within mission control centers at NASA and ISRO, teams are now developing specialized probes designed to enter the Venusian clouds and search for definitive evidence of these biological markers. Finding life there would shift our long-term objectives toward the possibility of building floating research stations suspended high above the scorched surface. Earth's deadly twin remains a puzzle that could hold the key to finding life in the most unexpected places. Tell us in the comments if you think humanity will ever build colonies in the clouds, and subscribe for more space mysteries.